How to configure horizontal pod autoscaler effectively in Kubernetes. Understanding horizontal pod autoscaler (HPA) configuration. The Kubernetes horizontal pod autoscaler (HPA) scales your application pods based on observed metrics like CPU or memory utilization. Properly configuring HPA ensures your application scales efficiently without unnecessary resource consumption or performance issues. Key concepts: resource requests versus limits. Resource requests: the minimum amount of CPU/memory guaranteed to a pod by the Kubernetes scheduler. This is what your cluster reserves for the pod. Resource limits: the maximum amount of resources a pod can consume before being throttled or terminated. Important: resource requests don't necessarily reflect your application's actual minimum needs, they represent what Kubernetes guarantees. Example: if your app normally uses 1 GB memory, steady state, occasionally bursts to 2 GB, a good setup might be requests.memory 1 GB, steady state, limits.memory 2 GB, peak use. Setting requests equals limits reduces eviction risk but can be less flexible. Choosing the right HPA utilization target. Why target 50 to 80% utilization? Many recommendations target 50 to 80% CPU utilization relative to the requests because it provides headroom for traffic spikes. It avoids saturating pods, which can cause performance degradation. It balances efficient resource use with responsiveness. What if you target above 100%? Targeting 133% utilization means scaling only when usage is well above the requested resources. This may delay scaling, causing pods to run hot and potentially degrade performance. Use this strategy only if your requests are set safely above typical usage. General guidance. If your requests are set at expected steady usage, aim for 100% utilization targets. If requests equal limits, guaranteed allocation, target lower utilization, 50 to 80%. Behavior and scaling policies. Your example configuration uses scale up window, 10 seconds, quick reaction to load increases. Scale down window, 5 minutes, slow scaling down prevents flapping. Scale down policy, max 1 pod per 2 minutes. These settings help avoid rapid scaling changes that can destabilize your workload. Limitations and advanced tips. Garbage collected languages, apps using languages like Java, Go, or Python may not return memory to the OS promptly, causing memory-based scaling to be less responsive. CPU metrics and I/O wait. If your app spends a lot of time waiting on databases or external I/O, CPU utilization may not fully capture load, affecting scaling accuracy. Custom metrics, monitoring thread pool usage, queue lengths, or other internal indicators can provide better scaling triggers but require extra setup. Summary. Set resource requests based on your app's normal steady-state needs. Set resource limits to allow for peak load bursts. Use HPA targets around 50 to 80% if requests equals limits, near 100% if requests reflect steady state. Customize scaling behavior to avoid rapid up/down fluctuations. Consider custom metrics for more fine-grained control. The goal is to make scaling responsive yet smooth, ensuring stability and efficient resource usage.